I'm feeling a little punchy this morning. A little Dr. Strangelove reference there. Is it 9:30? Is this clock really off? Okay, that's right. All right. Good morning, all. So, everybody got the handout of code for today? And yesterday's code went up on the web. I'll try to get today's up too. So if you guys want to play with the procedures, you can play with them, download it from the web, and play with them. You don't have to retype them. So today we're going to be talking about higher order procedures. And all those are procedures that manipulate other procedures. Okay, so I know you guys have started a problem set 2, so you've already seen some of this. You've seen how we can pass procedures as arguments. We can return procedures. We're going to be talking about this in detail today. In a language, first-class objects have certain properties. The first one is that they can be named. The second one, well, names by variables. The second property is that they can be passed as parameters to procedures. The third property of a first-class object is that it can be returned as the result of a procedure. And finally, the fourth one is that they can be included in data structures. So let's look at these 4 points. 1, they can be named by variables. Can we name a procedure by with a variable? Yes. How? Define. We've been doing that all along. So this is using define. Number 4 can be included in data structures. Well, we haven't seen any data structures yet. We will see data structures in the next few days. We'll be talking about lists, a way to build up lists and pairs and things like that. So let me just say soon on that. Okay. Steps, well, numbers 2 and 3, passing as parameters and returning as the results, we're going to see today. Procedures are first-class objects in Scheme. For those of you who know C, are procedures first-class objects in C? Can you return a procedure as a value in C? No, they're not first-class objects in C. But here in Scheme they are. We can pass them as parameters, we can return them, we can name them, and we can put them in our data structures. This makes Scheme an incredibly powerful language because we can do these things. So let's look at some examples of how we can, for the first one, pass them as parameters. The first thing I'd like to do is define a few procedures that do sums. The first one I'm going to define is going to sum integers from A to B. In this case, I've denoted A as 1 and B as 100. So we'll sum from A plus 1, A plus 2, up to B. So let's call this sum int of A and B. So if A is greater than B, what would I like to return here? 0. Our base case for addition is usually 0, multiplication is usually 1. Okay, if we're not at 0, what do we need to do? What would we like to do? Add the first term to the sum of the rest. This is the first term. Sorry, yes, up. Add the first term to the sum of the rest. Okay. Now, let's say we wanted to add a squared, a plus 1 squared, up to b squared. And I'll call this sum squares. Also taking in a and b. Well, I still want to check to see if I've done everything. I'm going to return a 0. Otherwise, what do I want to do? So if it's not our base case, we're going to square our current term, and then we're going to call sum squares on our next term and b. Okay, so we're going to operate on this and call with our next. Let's look at another one. Let's add a plus 2, a plus 4, up to the last odd before b. I assume there is some notation for that. Okay, and we're going to assume this starts odd. So I'm going to be adding odd numbers. So let's call this sum odds, taking in a and b. If, once again, otherwise we're going to add a to okay. Anybody noticing any patterns coming out here? I'm writing a lot of the same code. So what's changing?
Just the specifics of starting and ending.
Not even that, just the
No, the starting and the ending is staying the same, right?
Just the function.
That's all that's changing there. Obviously, this name is different, but it matches the name of the procedure. So the only thing that's changing in our pattern is what operation we're doing to our term, to our term, and how we're computing our next. So let's write a higher order procedure called sum. So we need some way to compute our term, which I'll call term A. Some way to compute the next value, which I'll call next, and B. Okay, so what should be the first thing in this procedure?
Term again?
term is a way to calculate the current term. It's a procedure. It's going to be a procedure. And next is the way to compute the next A for our recursive call. Yes?
Why isn't there a naming convention to separate procedures from variables? So you could just look at it and tell.
I don't know why there isn't.
Because they're the same.
Variable could be a procedure.
They're the same thing. They're not distinguished. Because functions are first-class procedures. Because procedures are first-class objects. Procedures are the same thing as a numerical value 3.
Sure, but I think the question is, if you're expecting a procedure to be passed in, could we denote this by term proc? And why don't we do that?
Typing, though.
Right, it's typing. But I think that was the question, right? Why don't we denote it somehow in the variable name?
Schemas untyped.
Well, it's not really typing. I mean,
I'm just saying in the name.
no, but just in the name of the variable, you're not actually typing anything by saying it in the name of the define. If you say term proc, you're not setting a type that is a procedure. But right, I mean, if it helps you guys to see that, you could certainly write something like that. It's not done in Scheme.
Could we start the ADU style?
I'm not going to go there. No. Look, if it makes it easier for you to understand it, you could name this term proc. It's just a variable name. You can call this anything in the world you want. You could call this proc dash compute dash next term, right? It's just a name. It doesn't change how we're operating or anything like that.
One difficulty, if we did make it too clearly linked with proc, sometimes we call it as, at least in the exercises, sometimes we call it just as simply a variable rather than calling it as a procedure. And it might get confusing if you're saying, well, this time I'm calling it as a variable instead of a procedure, but it says it's a proc.
Right. I mean, in this case, it'll always be used as a procedure. So in this case, you could. We typically don't. There just is no convention for that in Scheme.
It won't really always be used as a procedure if you're just summing integers, 1 to 10 or something. You're just using a primitive integer as term, so it wouldn't actually.
Oh, no, you won't be. Let's look at that. No, you will have to pass a procedure when we're doing the sum of integers. Okay, how would we write this procedure? Remember, we're only capturing, this stuff is different, right? So we're still going to have, okay, that's still the same. If A greater than B 0. Otherwise, well, we're still adding, that didn't change. Okay, so now we've hit one of these boxes. Term A. Do I want anything around term A? I'm applying term to A. And this is why term couldn't just be an integer being passed in. Because if we passed in the number 1, then we're trying to apply the number 1 to A. It doesn't make any sense. It's going to have to be a procedure.
But you can pass in plus.
But you could pass in plus. Right, and plus is a procedure.
Well, in this case, plus wouldn't make any sense.
It would work. Right. Right.
You can do that. Plus can take one argument and it'll return back that.
Just like we saw the other day for negation. I did a minus sign, space, and then the variable name. Same thing, any number of arguments.
If we had a negative number and we did plus, would it come out as a positive or would it still come out as the negative?
In mathematics, if you put a plus in front of a negative number, will it make it positive?
Well, it depends whether we're saying that. It depends how this works. In mathematics, if we put
For the most part, Scheme is modeling mathematics, right?
a plus in front of a negative, it's still going to be negative.
Right, if I say this, no, I have to put another negative sign in front of it.
But the negative reverses the sign.
Right, that's what we did when we wrote the
So
absolute value
plus
procedure
is
the other day.
different than the negative in this case. The negative will change the sign.
Right,
whereas the
negative
plus
change
is-
sign, plus is
does
just
not
doing anything,
change
right.
the sign, so they work differently.
Yeah, they have.
One affects the other, whereas the plus doesn't affect what's following.
There's a uniform way of thinking about it, which is that both of them, both plus and minus, when they have one argument, have an implicit second argument, which goes in front of it, in front of the first, which is 0.
Okay.
And so then there's consistent
Okay.
operation.
In a case like that, would it be better to use identity if you're going to do that than plus, or is it there's really, in your mind, not much of a difference?
See, I'm actually going to prefer to pass in a procedure. But because just I want to show you guys how to pass in procedures, right? So we're actually, let me finish this definition and I'll show you how we can call it. Okay, so we handled our first box. Let's get up to the second box. Okay, yes?
Quick question.
Mm-hmm.
So if you take that to our example, square would be the same, analogous to term, right? But what would be it for the first example, for some int AB? What would be the term?
Can we finish writing this and I'll show you guys how to rewrite those in terms of sum, and we'll talk about how to write those procedures.
Okay.
Let's just finish writing sum and then we'll make the calls to show you guys how to do it. Okay, we're going to call sum on, I hit a square. So now I need to think about what I'm doing. Okay, so this is something that's different. Well, I have this convenient procedure called next, which is a way to compute my next A. So sum next A B 1, 2, 3, 4. Oh, sorry, yes. Sum term next A next B. Yep, got sidetracked there. Let me rewrite that more neatly. So sum term next A next B. Okay. So let's do some rewriting. Let's rewrite sum int using our new sum procedure. Okay, up here I'm going to call it sum int on the board. In your code, it's called new sum int. The reason that I differentiated the new is if you want to load this entire code into your buffer and then try out the different procedures, one is called sum int, one's called new. So they have different names on your code sheet. So let's redefine sum int. Okay. So what do I need to do to sum my integers? To sum, well, let's do the easy parts. What's my second argument? What's my fourth? Okay. Easy parts, check. Let's fill in term and next. So in the case of sum int, we just want to add A. How can we write a procedure that takes in one argument, it returns the same argument? Identity. Lambda x x. Here. How do we get our next term? What are we doing here? We're adding 1. So lambda x plus x1. Okay, so now we've rewritten sum int using our sum procedure. We're passing some procedures as arguments. But that's cool because we can do that in Scheme. So let's look at sum int. Let's pick conveniently small numbers. 2, 4. What happens here? Well, that's sum lambda xx A lambda x plus x1 B 4. Okay, A greater than B? No. Plus lambda x x applied to 2. That's the term A. And then a call to sum with lambda x x. What's our A now? Next, lambda x1 plus x1 applied to 2. Our next function, 4. Okay. Plus 2 gets substituted in for x and returned. 2. Sum. Well, we got another call to sum. Well, we need to know what A is. We haven't computed it yet. 2 in for x plus 2, 1, 3. Is 3 greater than 4 yet? Did not pick a conveniently small enough example. So this becomes a call to sum of lambda x x lambda x x applied to B. So this is our next term, and then we pass our term rather. We pass our next, and then we pass B. Did we forget anything here? Yep. I really messed up the whole line. I messed up the whole line. Excuse me. Yep. That's what's good about blackboards. Okay, plus. Here's where we goofed. I forgot to add this in. Applied to 3. Now the recursive call. Sum with our term procedure, our next A, which we get by applying the next procedure. 2A, in this case, is 3, passing our next procedure, and then B, 4. Okay, there we go. One more paren. So now we have plus 2 plus 3 in for x, turns 3, 3, and a call to sum. This is now 4 plus.
5, you don't want 5.
Hmm?
No, that's 4, then go back to move on to 5. But then we check.
No, but then we'll check. Remember, we're doing a check to see if A is greater than B. So here we have lambda x x applied to 4. Sum lambda x x lambda x plus x1 applied to 4. Our next procedure, and then 4 still. 4 parens there. Finally, getting down to plus 2, plus 3, 4 in for x, returning 4. Now, sum. A is now, 4 in for x plus 4, 1. 5. Is A still greater than B?
Yes, that's right.
So we were
A is greater than
Yeah, if A is greater than B, A is greater than B, return 0. Sorry. Yeah. 4, 0. Thank God. Okay. 4 plus 3 plus 2. 7. 2 plus, giving us 9. Once again, running out of board space.
The A that's greater than B is 4, not 5.
No. I'm calling, this is A here. 4 goes in for X plus X1. A is 5. 5 is greater than 4. And we're out of there. So a little review of yesterday. It's a recursive what? Process. And is also a recursive procedure. Okay. But the process is measuring this shape, the amount of space we're using. We're delaying one operation for every n. So in terms of space, this is theta n. How about time? Theta n. One step for every n. That's a little review yesterday.
Unless we know the innards of every procedure passed in, we can't say whether sum is recursive process or iterative process. I'm sorry. Here it's
very clear.
A recursive process.
It's a recursive process, and you know that we're doing it.
Iterative, we have to know about next in term to be able to say accurately whether this.
Right. So we're making some assumptions when we compute theta. And we're assuming that things like this are unit procedures.
I meant more term.
Right.
Next.
But term and next, certainly if we were going off and doing something more complicated. Did you show them an example of a station yesterday where order n was calling order n? Okay. You talked about it? Okay. Basically, if we were calling something, if one of our, let's say, term was something of order n, so we have something of order n using something of order n, that would give us order n squared. Okay. So in this case, term and next are basically what we would call sort of unit operations, so not doing anything complicated. Right? We're just either returning the identity, poof, or we're adding one. We'll call that unit operation. It's not going off and taking linear time and doing anything else. Okay.
Sum int is clearly a recursive process because it calls a recursive process. But is sum int a recursive procedure?
I think you just flipped what you were asking. It's clearly a recursive procedure because it calls itself. Okay? You don't have to know anything about the use of space to know that it's a recursive procedure. If you just see this, if it's calling itself.
But it's got to be, if it's a recursive process, some int is not recursive.
Sum int is not a recursive procedure.
No, this sum int is not.
Okay.
No, because it's merely calling sum.
But it is a recursive process.
Right, it's a recursive process. Well, no, sum is the recursive process, right? It's calling a recursive process.
But it's not a recursive procedure.
Right, yes. Right. I should have gone with the new sum ints on the board, too, so that I knew which one we were talking about. Yeah.
Recursive if it calls a recursive? Is that what you're saying?
It's a recursive procedure if it calls itself. Now, this is calling a recursive procedure, but it's not calling itself.
So technically it's a recursive process, but then not a recursive procedure.
Yeah, which is just ugly, isn't it? Yeah. Well, so we should say it generates a recursive process, right? So it's calling something that generates a recursive process. And that change to the language will actually make everything work out just fine. So when all else fails, change your language. Yes?
Okay, can you go from the second to third line for me on that?
Second to third. Okay. So this here is term A, next B. So A2 is not greater than 4, therefore we're going to add term applied to A. That's the first part of our plus there. We're adding that to a recursive call on sum using term. And then we need to pass a new A. Next applied to A. This is next. This is our A. We pass the next procedure, and then B. Other questions? Okay, let's rewrite some squares. May I erase this so I can write some squares underneath it?
Just on the equation.
Just on the thing you just erased. Yeah.
Where we're equating recursive processes with time and space, with linear time and space.
Okay, so a recursive process is saying nothing about time. When you say iterative process or iterative process or recursive process, all we're talking about there is what are we doing in terms of space. Okay, it's nothing in terms of time.
Right.
Okay, so if it's constant space, it's iterative by definition. And if it's not iterative, then it's a recursive process because we're delaying some operations.
Right. And then as far as saying whether the space, we said it was linear in that example, right? It was theta n.
Right, we had one delayed operation for every n.
Right. Okay.
Right, so in terms of space, it was linear. Okay. And because it wasn't constant, it was a recursive process. Yes?
And time is just a number of steps that you go through.
Right. Time is the number of steps.
And it's, if you skip like every other step, like increment by 2, that doesn't really change the time. Because that'd be just n over 2.
Right, which is a constant which drops out in our theta notation.
So again, you said we learned nothing about the time notation from whether it's recursive or iterative.
Right, if I tell you this is a recursive process, if I say this is an iterative process, one thing you can say for sure without looking at anything is space is constant, there are no delayed operations. But you can't say, well, there are iterative processes to do lots of things. We saw some yesterday that had time n, that had time log base 2 of n. So there are iterative processes there that have different time scales. So the iterative process itself tells us nothing about time.
And it doesn't tell, all it tells us is that the fact that this was recursive, all we knew from that was that it wasn't constant. It could, the space.
Right, that it was a recursive process told us that it was not constant space. So it didn't tell us how much space it was taking.
Right, okay.
So we could have been delaying n operations, n squared operations, log base 2, n cubed.
Specific answers because we could actually look and
Because we actually had the code to look at. Okay, that's where we got the specific answer from. Let's rewrite some squares. AB. So, I am going to do the easy parts. You are going to do the hard parts, but don't look on the sheet because they're there. Okay, so what should we write for our term function? What are we doing in sum of squares? We're squaring it. So, what could we do? We could write a couple of different things. We could write lambda x times xx. Could I have done instead that? Yes. Oh, yes. If we had defined squared, in fact, if we were using it over here, hopefully it was defined somewhere. And it's defined in the environment. You don't actually need to define it. Okay, so either of these do exactly the same thing because it looks up square and it's bound to this procedure and it pulls in that procedure.
In the case of square, we just say lambda x squared x, right?
You could also say that.
Oh, you have a better idea. Oh, you just pass the procedure. Smarter than me.
Those are 3 different ways to do exactly the same thing. Okay. But you wouldn't actually write all 3 of those things, right? You'd pick one. Otherwise, we're going to have way too many parameters. Yeah, randomize which way we're going to call. There you go. Next, what are we doing to calculate our next term? Lambda x plus x1. Or, as John said before, it's increment, isn't it?
Yeah. No, I think it's INC.
Is it INC? Okay. Two ways. I'm sure we could come up with more convoluted ways to do this, but let's just go with those two. Okay, while we're on a roll, let's do some odds. Call to sum. A, B. I'm done. Your turn. What are we going to do for our term? Identity. What are we doing for our next? There is a space there. Okay. Questions about passing lambdas, passing procedures? Yeah.
Would there be a way, if for some reason you wanted to do that, to call the inc function twice in order to have that be your next term, rather than doing lambda x plus x2? Did you do inc x, inc x? Oh, inc x, okay.
Yep.
How about if you were doing something where you want to, for one of the procedures that you pass the sum, except another there. How can you do that? Well, I don't know how to ask this question without pointing directly to the problem that it relates to. But there's a problem where you have to find, the question where you have to find the numbers that are relatively prime.
Wanted an A. Here, we only wanted an A. Here, we wanted a square A.
Right.
So
the plus is already in there.
well, the plus is part of the procedure, right? So all we're trying to get is the term. Okay. We're not actually doing the addition with that lambda. All we're trying to do is pull out this term that we're adding. Mm-hmm. So whether that be the term itself, it's not nothing. It's the term itself, right? So it is, in fact, something. But we just want to take that A in and return A. We don't want to actually operate on it.
So when we defined the original sum one, way over here, we sort of said term was a procedure, but here we're saying it's sort of a procedure that does nothing?
Oh, it's definitely a procedure. I said it's going to be a procedure, a way to calculate the current term. I never told you what the body was going to do. It's a procedure. It is a way to calculate the current term. And the way to calculate this current term is if you give me a number, I'll give it back to you.
Okay.
That's a very valid procedure. Or in the case of the homeworks, you guys you'll see one where it's lambda I1. No matter what you give me, I'll always return 1 to you. It's a procedure. It's a valid procedure. Just returns 1 all the time.
All right. If you knew what it was going to do, could you, instead of writing lambda, just say, well, A, it's for term?
Well, let's look at what would happen if we changed that to, say, A.
Would your A's conflict because it would change as well?
Well, what we're doing is we're passing a number in, right? So when we come over here, we're going to try to apply A to A, which it has no meaning. You can't apply a number to a number, right? So we're going to get an error there because it's not a procedure object that it can apply. Okay?
I think kind of what she's getting at is that this makes it more powerful that if you want to do other stuff to A, you need to have the term there so you can square it or cube it. And then you realize that, oh, well, if I don't want to do anything to A, I've got to put something in there to hold this place.
Right.
And so it seems like, well, if we had written originally that there was no term before A, then we could skip that step.
Sure, but then we wouldn't be able to write some squares.
Right, you wouldn't do anything else.
Right. So we could write something of sum only if we don't change A on A next in B or something like that. But then we're writing multiple procedures the same thing. Right. But that's what we could have done, yeah.
Just a style question. You could like define some integers with 2 arguments and then go to a call with more arguments. You could just move that up too.
I mean, I could have had just I could have had a list across.
That's just so it looks cleaner on the outside.
It's a little bit easier to read. It was definitely easier for me when I was writing it because I just said 2, 4, and I left holes for 1 and 3. Whereas if I had written 2 and 4 and I didn't know exactly how long these procedures were going to be, then I would have written my A and left some amount of space and I might have been squishing inside of it. But yeah, this is stylistic. If you've got a lot of parameters and the parameters are long expressions, it does look cleaner to put them down like that.
No. I meant on the first line there where you define sum int A and B, you could have the term with an X in it too.
Could I? Because then what happens when your user says, I want to sum ints? So now I can say I want to sum integers between 2 and 32.
Yeah, they would have to have all of those.
They would have to give you term and next, right? And you don't want to do that. I mean, because it's going to be the same every time anyway. Let's wrap that, take that away from the user, and then the call. So to a user, it's completely transparent whether we have this body or whether we have this body over here. The user has no idea how we've implemented some ints. They're just calling it with 2 numbers. Yes?
So my abstract procedure is going to be defined, like in this case, above the blackboard in order to call some ints later. I'm going to have the term and next and all that, the whole procedure defined already.
It has, well, before we make this call, it has to have been evaluated in the environment. It doesn't necessarily have to be written above it. It just has to be evaluated. It has to already be evaluated in the environment. So if we are writing a code file and we want to do, actually that doesn't matter either. It doesn't have to be above it as long as it's evaluated. The ordering in the file doesn't matter as long as it's evaluated. Right. Because remember, the body of a lambda, which this is not evaluated until we apply it. So if we come in here and we do sum ints and we evaluate it and let's say sum is below it, it doesn't matter because we've never looked inside of that yet. When we go to apply it, then we're going to look to see if it's out there in the environment. So it could have been evaluated afterwards. It doesn't really matter because it'll be there in the environment for us to use.
So it's only when I type in sum ints 2, 4 that it's...
Right, that we're actually doing that evaluation. And at the evaluation point, this needs to have been evaluated. This needs to be defined in our world.
So you couldn't put sum int 232 before you type in define sum int A, B, sum whatever.
Right, I mean, you can't make a call to something you haven't defined, right? So, I mean, if you type in define A3, define B2, well, then I can add A and B. But what if I just say plus AB and I've never defined A and B? There's no meaning to it, just like you can't use a procedure if you haven't defined it yet. You can't use a number if you haven't defined the variable. Okay. Yes?
Can you define a function before and then send it to send it to another function or procedure outside of the, like let's say you define square before sum. See this sum squares?
Sum squares. So let's say here.
In there you had to define square.
Let me call it SQ instead, because square is actually defined in our environment, and then change this to use SQ.
Okay, so when you call the sum procedure, you could send an SQ even though it's defined inside the procedure, and it's going to another procedure external.
Right. Okay, and this is going to come out in the environment model, and I know I promised you guys a lot on this one, but we'll see how when we evaluate this lambda, we're going to create an environment. And then this is going to be evaluated in the environment where this has already been done. And then the calling will be back. Anyways, let's wait till we get there. I keep promising you guys this, and you'll see it, and you'll be like, wow, it's so cool. Or you'll be like, oh, my God. In any case, so it'll be fun. Okay, more questions on this. What I would like to do, actually, let's do one more sum. One more sum. I want to compute. So, sum I equals A to B. I cubed plus 2I. How can I write this? Oh, let me define YAS, short for yet another sum. AB. Well, next is pretty easy. Let's do that first. What are we doing to get our next term? Or incrementing. How do we get our term? Or lambda x, lambda I, whatever, sure. Cube x. Can I write cube? What would need to have happened if I write cube? It's going to need to be defined somewhere. Plus sorry, yeah. Someone said I listened blindly. Close. So this is this. So check. Okay. Just passing procedures to do stuff for us. Any more questions on passing procedures around? Because next we're going to move on to returning procedures. Let's do it. Yes! Very exciting. Let me put an exponentiation procedure up on the board. Takes a b and an n. If n is equal to 0, it returns 1. Otherwise, we're going to multiply b times the exponent of b and minus 1. Does not handle negative exponents, right? It's only going to handle positive and 0. So, what I want to define is a procedure called make exponent. And what I want make exponent to take is the power that we're going to be making it for. So let's say I could write square in terms of make exponent. We'll see that in a minute. And let's find this to be lambda b exponent bn. I could then write define square, rather, without the paren, 2b, a call to make exponent 2. And square 3 would return 9. What's going on here? I see lots of people going, oh boy. Okay. I've written an exponentiation procedure here, and it takes in an argument n. So the lambda takes one argument, whether it be 2, 4, 100, 500. And it's going to return a procedure. So it returns a procedure that takes one argument, b, our base. It makes a call to exponentiation with b and n. So here what I've done is I've defined square to be the procedure returned from a call to make exponent on 2. How would I write cube? Why am I not putting parentheses around cube? This is our name, and we're going to bind it to be the procedure returned here. If I mistakenly put in parens around cube, this would now become lambda of no parens, lambda b, exponent b3. So could I say cube 2? No, right? So what would I need to write instead? That wouldn't work that way. What would I need to write? Well, I'm still going to write cube, and I'm still going to write 2. But cube needs to go in parentheses. Why? Because cube is a procedure, takes no arguments. When we apply this, then we would get back lambda b x b3 and applied to 2. Then this would come in and we'd call x on 2, 3. Are we going to want to do something like this for our procedure definitions? Probably not. This is pretty twisted, right? That we have to force an extra layer of evaluation. But if when you're writing some higher order procedures, you find yourself getting procedures returned when you expected values, you might want to double check to make sure that you didn't accidentally do something like that. That could cause some problems. Good. The last thing I want to show you guys today.
I'm sorry, did you say all those bad things on the bottom would only happen if you had those extra parens?
Yes. So if we take out those extra parens, then this goes away, then this call becomes correct. So the only bad thing that we did, well, only, but it was very bad, was putting those parentheses in. Because basically, this is the sugared version. Remember at the first couple of lectures, we kept writing define, name, lambda, parameter list, body. Okay? So we want, in this case, this is going to be returning a procedure. We're binding a name to it. When we put those parens around it, then we're adding another layer of a procedure wrapped around the return procedure. Which is not a good thing. Bad. Bad. Bad chalk. Yeah. The chalk didn't even want to touch that example. Okay. Today I'd like to show you another special form. Special form is called let. Let. It takes the form let, open paren. Then we're going to have the list of variables. Variable 2, expression 2, there n, expression n. We're ending the list of variables. And then we have the body of our let. So what does a let do for us? What a let does is it allows us to create some local variables. These variables here can be used in the body of our let. And when our let ends, when we exit out of the statement, those variables are gone. Just like if we have a define with some variables we're passed around if we have a procedure that we're running, we exit the procedure, they go away. So these variables can be accessed in here. nowhere else. The let is actually just a fancy way to write a lambda. I'll show you. This is the same as lambda var 1, var 2, var n, body. The first thing that we do is we evaluate the values of our sub-expressions with the words, what after that? In any order. Meaning that you may not, in expression 2, use variable 1. Okay, you can't do that with a let because it desugars into this lambda. The sub-expressions are evaluated and then they're substituted in. Now, if you did want to do that, there is another special form for that, which we're not going to go into detail on today. You'll see it later. That's called let star. Okay, so it does exist. We're not going to talk about it today, but just to let you know, there is one out there.
Wait, so the values in the expressions are being assigned to the
values of the variables. So let's actually write a concrete example.
The variables are just variables. Those should have parentheses around them, right?
They don't have parentheses around them, right?
Right, they don't.
Those are little brackets. So let's let A be 2, B be 3, and C be plus 4, 5. Then I'm going to add A, B, C. Okay, let's rewrite this. This is the same as saying lambda A, B, C of the body plus ABC applied to 2, 3, plus 4, 5. So evaluate the sub-expressions. 2 is 2, 3 is 3. This is 9. Substitute 2 for A, 3 for B, 9 for C, plus 2, 3, 9, giving us 14. Okay. Same thing happens over here in Letland. It's the exact same thing. It just desugars, just like we showed you define, paren, name, and then the parameter list close is the same as saying define, name, lambda, parameter list, and then the body. This is another one that desugars. So in this case, we don't know what order we're evaluating these in. Once they're evaluated, then the values are bound, and then they can be used down here. So, yes?
Again, I'm assuming then that you could use let, like a define inside a procedure and put defines inside a let. Maybe we want to define a procedure inside a let, or put a let.
Sure, we could create some local variables and then define here. But remember that define will only be, that procedure we create using define will only be scoped, will only be able to be used within the let. Once we come out of the let, it's gone.
Could we substitute A for 5? Let C be 4 plus 5?
Okay, so this is actually an example that, it's actually a good example. Let's do it. So let's create some global variables. Let's create A to be 1, B to be 2, and C to be 3. Now, I'm going to say let let's say, let A be 5, let B be 6, and let C be A plus B. What is this going to evaluate to?
Depends on which order they're evaluated.
Does it matter what order they're evaluated in?
Yeah, 5 and 6, A and B were evaluated by chance. Just by chance.
Okay, so I'm hearing, okay, if we evaluate 5 and 6 first, then these A and Bs are going to be 5 and 6. That is not right at all. Wrong. Because this desugars to lambda A, B, C plus A, B, C applied to 5, 6 plus A, B. Where are those A and B coming from? These. It doesn't even know about this A, B, and C here. Doesn't matter what order we're doing this evaluation in. It will not know about this A or B. These bindings are not completed until we've evaluated all of those expressions. So this evaluates to, well, what's A out in the global? 1, B is 3, giving us, well, this goes in 5, 6, 3. We're adding 5 plus 6 plus 3, giving us 14. Coincidentally, the same number as the last time. Yes?
Is let pure sugar? Or is there any extra power with it?
Pure sugar.
To me, in this example, it doesn't seem easy to write let on the track, right? So how come you have the special let form instead of just using
This might be a little bit easier for someone to read because the variables are right up front. Right, so you're seeing what's being assigned into A, into B, into C, and then the body. So it's just another way to write it. It might be an easier way to read it. Because if you look at this, you say, okay, a lambda ABC, and then I got to look down here to see what they're being bound to, and they're spread out a little bit more. It's just another way to write it, and you might think of it as being just a clearer way to see it.
If I substitute for let, define A5, define B6, define C, A, and plus AB, then the sum is done.
Then the sum would be, yes, 22.
So in this case, let does a different thing than defines.
Well, plus these are evaluated up in our, our regular environment. Our global environment is doing a different thing. It's definitely doing a different thing. Right, because if you did defines one by one, it does the bindings one by one. Let does all the bindings after it's evaluated all of those expressions. So they are very different.
Now, with the lambda statement, we say defining a procedure. We don't know what our inputs are going to be to the procedure until we use it somewhere later. So in that case, let wouldn't have any use. So when does let have a use?
We can certainly write this. I mean, you can write procedures in which you have what they're being called on right here.
Right, but say you're making a procedure called add 3, and you define it as lambda ABC plus ABC, and then you're going to use add 3 later on 3 numbers. Right. So so those numbers aren't there yet, and so is there any way for let to be of any use, and if not, when is it of use?
Well, you could think of, let's say that we were trying to solve an equation where we had 2 terms Do a quick and easy. Yeah, so basically if you have some computation, so basically what let's good for is if you can compute, there's some small set or some set of variable values that you're going to be using repeatedly. So that's what it's good for. Let's say that, in these cases we've been doing things very simply, but let's say that we're going to let A be some result of, well, let's just make them numbers again, I guess. A be 2. And here we could actually be calling the square of 16, and C be some int 1 to 100, 1, 2, 3. And then in our body, we could be doing things like, well, what we want to do is we're going to add the square of A to the square of C, and then we're going to multiply, the cube of B times the cube of C, something like that. So in this case, we're saving ourselves some computation by doing it here, because otherwise, we're calling C here, we're calling C here.
Seems like it would also make it very easy to comment on what each one of the variables would be, not to the right.
Yeah, certainly. I can't fit the as, unfortunately. Okay, so yeah, you could comment what each of the variables are. So this is good to eliminate redundant computations, because we don't want to call some int a couple of times. Or, God forbid, we were calling, Fibonacci written stupidly many times, right? So we're calling an algorithm that's 2 to the n like 4 or 5 times. We'd want to compute that once and then use the returned value as many times as we needed it. So that's what let is good for storing, to avoid some computation later on. Yep.
I'm not going to bring up let star, but kind of along those lines. Is nested let something we can do?
You can nest a let. Okay, so I really don't want to get to let star, but effectively with let stars, it does them in order. Okay, and you could do a let and a let and a let and a let. Okay. So the question is, could I say let A be 1, then have let B be 2, and then let C be A plus B?
Right. And you get 22.
No, actually we would get 6, but in this case A is 1 and B is 2. But yeah, if I were using the same numbers as before, yes, we would have gotten 22. So.
You can also nest a let by saying, say, let A, and then the value would be let, and do all this computation.
Oh, God, no. Yes, but it's just really ugly. No. You saw that John and I both at the same time went, no. You could do it, but no.
So
let's not go there.
That is, in essence, a nested lambda statement, then?
Yes. Well, let's desugar it, sure. Easy for John to say, sitting on the chair there and not having to write everything out on the board. Oh, I see. Okay, yeah, we could do that. There you go. Yeah, that's right. This is left as an exercise to the reader. You guys can desugar this, and if you want, John can pop up the answer in recitation today. I win. That's actually would be a good thing for you guys to do, to see how the lambdas are working. Do you guys have more questions on let? This is as far as I wanted to go today. If you have no more questions, go off and work on problem set 2.